Good morning, grade 10s. Today is the 3rd of March and we are on our 4th lesson of e-learning and it is Friday. So could you please open up your books and write today's date, the 3rd of the 4th, 2020, and your heading quadratic expression. Right. So you have seen a trinomial in grade 9, and your trinomial was 3 terms that came in the form of x squared plus bx plus c. And sometimes there was an a coefficient of x squared. And in grade 9, that coefficient of x squared always turned out to be your HCF. But in grade 10, we're going to show you how to do a trinomial that comes out in this form, where x squared has a coefficient, where b has a coefficient, and c, the constant term, has to be factorized without being able to take this out as your HCF. So this is your grade 10 trinomial, and it works. There are 2 different ways to do it, and I'm going to show you the one way. If you get back to school, perhaps your teacher's more comfortable with the other way, and she can show you that way. If I can just remind you what grouping was, where we had 4 terms and we had to take out a common factor. So if I had, and this is coming on my, let me try to see if I can quickly find one. So if I had, for example, ax plus ay plus bx plus by, okay? And I told you to factorize this. Can you remember how to factorize 4 terms? You group them. You look for an HCF between those 2 terms, and you looked for an HCF between those 2 terms. So what happened? Here you took out an A, and you're left with x plus y. And here you took out a B, and you were also left with x plus y. What do I notice? Common brackets. So you would take out the common bracket of x plus y, and what were you left with? A plus B. And that would be your answer. So it's this idea of grouping that I'm going to draw on to do our quadratic expression for grade 10. Let's look at our first example. Example 1 looks like this. It says factorize 2x squared plus 5x plus 3. So usually in grade 9, you would be able to take this out as an HCF. But can you see that 2 does not fit into either of these? Okay. I want to expand, or I'm going to expand these 3 terms into 4 terms. And how am I going to do that? I'm going to rewrite 5x in different ways. So do you agree that 5x can be made up of 1x plus 4x? Or perhaps it can be made up of negative 1x plus 6x. Or it could be made up of 2x plus 3x. It can be made up of a whole bunch of things. So I'm going to rewrite 5x into 2 terms. Because if I rewrite it into 2 terms, I will have 1, 2, 3, 4 terms altogether, and I can do grouping. But the trick is to decide which 2 terms I write 5x as. So this is what we do. We take the coefficient of x squared and we multiply it with the constant term. That gives me a result of 6, okay? Now I find the factor pairs of 6, just like we would in a normal trinomial where we find the factor pairs of the constant. Here we find the factor pairs of 6. So my factor pairs are 1 and 6, 2 and 3. Okay, and we're still drawing on knowledge from our normal trinomial. In our normal trinomial, remember this plus tells me that I must have the same signs, and this indicates which signs I must use. So I'm going to do the same thing. 5 must be broken up into 2 of the same signs, and those signs are going to be pluses. So plus and plus. I keep the 2x squared. I keep the 3. But which terms am I going to use? Which factor pairs am I going to use? Both adding to get to 5x. Well, I'm going to use 2 and 3. So plus 2x plus 3x. Okay, so do you see how I've broken 5 into 2 terms? 2x plus 3x gives me 5x. And now I'm just going to group. I'm going to find an HCF here, and I'm going to find an HCF here. So what is my HCF here? It's 2x, And when I take 2x out, what am I left with? I'm left with x plus 1. And here, what is my HCF? It's 3. So I'm going to take 3 out. And what am I left with? X plus 1. And what do you know? I've got common brackets. So I take out my common bracket of x plus 1. And what am I left with when I take out x plus 1 here? I'm left with 2x plus 3. My Koki pens are very dry today. I don't know why. And that would be my answer. So let's look at another one. That was example 1. Let's look at example 2. It says 6x minus x minus 2. Do you agree that 6 is not an HCF? It does not fit into any of these terms, remembering that there's an imaginary 1 standing there. So 6x squared, by the way. Sorry. So what do? I can't factorize that out, so I take the 6 and I multiply it with my constant term. That gives me 12. So, what are the factor pairs of 12? 1 and 12, 2 and 6, 3 and 4. Okay, this sign tells me what? If I had a normal trinomial, that I would have to break it up into a plus and a minus, that they must be different. I keep the 6x squared and I keep the minus 2, and now I need to break negative 1 up into two numbers that consist of a plus and a minus. Which one am I going to use? I'm going to say minus 4x plus 3x. I'm using that factor pair, because plus 3 minus 4 gives me negative 1. And now what do? I find an HCF here, and I find an HCF here. So what is my HCF here? It's 3x, and when I take 3x out, what am I left with? 2x plus 1. And what is my HCF here? Let's think cleverly. It's not just 2, but rather negative 2, because that leaves you with 2x plus 1. If you had taken out positive 2 and not negative 2, you would just have had to do sign change, and then you would have landed up with the same expression as I did. And what do I see? Common bracket. That's exactly the same as that. So I take out my common bracket of 2x plus 1, and what am I left with? 3x minus 2. And I factorized my trinomial. That's example 2. Let's look at example 3. I'm just going to write in this blue because I think it's writing the best right now. 3x squared plus 4x minus 4. Okay, this is example 3. 3 can't be factored out, so I have to do my grade 10 trinomial. What do? I say 3 multiplied with 4, and I get 12. What are the factor pairs of 12? We just wrote them down. 1 and 12, 2 and 6, 3 and 4. Okay, let me quickly decide what signs. If this is a minus, what signs must I use? I must use different signs. So I have a plus and I have a minus. I bring down that 3x squared and I bring down that minus 4. They don't change. How am I going to break this 4x up using a plus and minus and these factor pairs? I'm going to say plus 6x minus 2x. And that gives me to 4. And now what do? We just find our HCF. What do I take out here? I take out 3x, and I'm left with x plus 2. And what do I take out here? I take out negative 2, and I'm left with x plus 2. Again, if you had taken out positive 2 and not just negative 2, you would have had to do sign change, and you would have landed up here. I note my common bracket. So I take my common bracket out, and I'm left with 3x minus 2. Remember, when I take my common bracket out, it's as if I divide each side, each term rather, by the bracket. Because it's a monomial over a monomial, I can cancel. So do you see I'm left with 3x minus 2? That's example 3. Now I'm going to do example 4 with you. It says factorize 2x squared minus 9x plus 4. Again, I just check, can I factorize this 2 out? No, because 2 doesn't go into 9. So I have to do my quadratic expression that we're learning in grade 10. I say 2 times 4 is 8. Factor pairs of 8, 1 and 8, 2 and 4. What does this plus sign tell me? It tells me that both my signs must be the same, and it indicates that they must both be negative. So I'm going to split 9x up by saying minus something, but I'm going to bring my 2x squared down, and I'm going to bring my plus 4 down. So what factor pairs am I going to use to get to negative 9 using two negatives? Well, I'm going to say negative 8x minus 1x. Do you think it would have mattered if I said negative 1x minus 8x? I can assure you it doesn't matter either way. You can try it. You'd get the same answer. In fact, I'm going to do it this way so that you can see it doesn't matter. So what is my HCF here? My HCF is an x. So I take x out and I'm left with 2x minus 1. And what is my HCF here? Let's take out 4. So I take out 4, and I'm left with negative 2x plus 1. I wasn't clever in my taking out my HCF, because what do I notice? These two brackets are similar, but not exactly the same. That means I have to do sign change. Remember sign change? I change the outside sign of a bracket, and the two inside signs change. Just before I do that, how do I know they're similar? This is positive 2x, but this is negative 2x. This is negative 1, but this is positive 1. So I have to do sign change. Changing the outside sign means I can change the first bracket's inside signs. So this stays the same. I change this to negative 4, and what am I left with? Positive 2x minus 1. And aha, identical brackets, which then become my HCF. So I take my 2x minus 1 out, remembering it's as if I'm dividing each term by 2x minus 1 by 2x minus 1, which means I can cancel these things because monomial divided by monomial. And what am I left with? X minus 4. And that's my answer. I'm being very lazy. Sorry. Every sum I'm meant to be running equal signs down the side. And that was example 4. Let's take a look at example 5. Example 5 tells me to factorize 2x squared minus 5xy minus 3y squared. So this looks different because previously we would have left that y out, and that's what it would have looked like. But here we've added a y in. So let's see what happens. Doesn't act any differently. I need to break this up into two parts. So I need to say, for example, plus 1xy plus 4xy, and that would give me to 5xy. I still multiply the 2 with the 3. So what is 2 times 3? It is 6, and my factor pairs of 6 are 1 and 6 and 2 and 3. I decide on my signs. What are my signs going to be? Different. So I know I'm going to make negative 5x up by saying plus something minus something, because that tells me it must be different. I bring down my 2x squared. I bring down my negative 3y squared. Remember, this negative belongs with there. It doesn't indicate that negative. And now I choose my factor pairs. Which factor pairs using a plus and a minus am I going to get to negative 5? Well, I'm going to say minus 6 plus 1. So plus 1xy minus 6xy. I've used this factor pair. Again, if you'd swapped this and you had said 2x squared minus 6xy plus 1xy minus 3y squared, it wouldn't have made a difference as long as the 6 has the negative, because I need to subtract 6 and add 1 to get to negative 5. Doesn't matter if you switch them around though. So I've broken 5xy into two parts, not forgetting that this is an x and a y because I need to get to 5xy. And what do? I've got 4 terms, so I just group. The thing they have in common here is an x, so I take x out. There's an x and there's an x. And what am I left with? 2x plus 1y. I'm just going to write y. Remember, when I take out an HCF, it's as if I divide each term by it. So that would cancel one of my x's, and I'd still have, would cancel one of my x's, and I'd still have x. And this would cancel that, so I'm just left with y. And what do I take out here? I'm definitely going to take out a negative. I'm going to take out negative 2y, because 2 can go into both of them, and they both have a y. And what am I left with? Sorry, not negative 2, but rather negative 3 can go into both of them. And what am I left with? 2x plus y. How did I get that plus? When I divided this by negative 3y and I divided this by negative 3y, the negative and the negative became a positive. 6 divided by 3 is 2, and the y's cancelled. Here again, the negative and the negative became a positive. The 3's cancelled, and I took one y away. And what do I notice? Two brackets that are exactly the same. So I take out, again, I'm not running my equal signs. I take out my 2x plus y. And what am I left with here? X minus 3y. And that was example 5. Last example I'm going to do with you, and this one is a little bit more tricky because it deals with very funny exponents. X to the power of 2a plus 2xabby. This is example 6. Just a side note, please remember that if I have x to the power of 2a, it is not x squared times xa. Because if I was multiplying, what do? You keep the base and you add the powers. That is not what I'm doing, okay? I've got 2a. So what does this actually mean? It actually means x to the power of a times x to the power of a, because my exponent laws tell me keep the base and add the powers. A plus a is 2a. So same here, if I had b to the power of 2y, it is not b2 times by, because that would indicate b2 plus y. That's not what I want. I want 2y. So that means I've taken b to the power of y times b to the power of y, which equals b to the power of y plus y, which is 2y. Just a side note. Okay, so what am I going to do? I'm simply going to multiply. Okay, I'm going to multiply x with b, and what do I have? I have xb. How do you think I make up xb? How do you think I have... Okay, so let's rather think of it like this. If I had xa, like I said here, this was xa times xa, and this was by times by. Do you see I only need one xa and one by? So, just thinking a little bit cleverly, how could we break this up? Okay, this is easy to break up. This is simply xabby plus xabby. Look here, the plus tells me they must both be the same, and that tells me they must both be positive. So what's 1xabby plus 1xabby? Well, it's 2xabby. This one takes a little bit of thinking, so you bring this down, x to a, and you bring that down, plus b to y, and now I can factorize by using grouping. So what do? I take out an HCF of x to the power of a, right? So when I take out x to the power of a, what am I left with here? Remember, this was actually xa times xa. So if I take out one of those xa's, what am I left with? I'm left with xa. And when I take out xa here, I'm left with by. Okay. On this side, what is my HCF? Sorry, this is b to the power of y. On this side, what is my HCF? Remembering that this was by times by, I have an HCF of by. So I take out by, and what am I left with here? I'm left with xa plus, if I take out one of these by's, I'm simply left with by. And what do I now do? I see, common brackets, x to the power of a plus b to the power of y from here, and that means I divide each, xa plus by, all over XA plus BY. Cancel, 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 cancel. And I'm left with XA plus BY. And to show your marker you're really smart, if I'm multiplying the same thing by itself, what happens? XA plus BY squared. Okay. Can I just quickly clarify what I did over here when I took out XA? This was split into XA times XA. So when I took out XA here, okay, it cancelled off one of my A's. So I had one A remaining. When I took out XA here, that and that cancelled. So I had BY remaining. So the same when I took out BY between these two terms. If I took out BY here, the BY and the BY cancelled and I was left with XA. If I took out BY here, as I explained, one BY would fall away. Okay, so that is the examples that I have for you, and you're welcome to go rewatch the videos. Example 6 is a level 4 question, so that's why it is a bit more difficult. You can go now to look at exercise 3 at the bottom of the page, and because this is very new to you, the more you do, the better you'll become. Let me just zoom it in right in so that you can see. So the more you do of these, the better you will become. What I can suggest is please always check if there's an HCF first. So just looking right now, from my point of view, I can see it, oh, there's definitely an HCF that you may have to take out first. So please check that with all of them, and good luck. I hope you enjoy this part of your maths for grade 10.